All right, guys, we're back at it here. We're going to move on to a new chapter. It's going to be chapter 5.1 and 5.2 this first time. We're going to go over function operations, and then the second part, we're going to go over inverses. So if you're looking to revise your notes, examples 1 and 2 on 5-1 and section 5.2, example 2 for the next part. So this part here, function operation, you're going to see terminologies that look like this, like f minus g of x, f plus g of x, f times g of x, and f divided by g of x. I need you guys to kind of look at it a little differently, and all it really is saying is f of x minus g of x. That's what that said. These two things say the same thing. So then we got f plus, f of x plus g of x. Then we've got f of x times g of x. And then this last one, we've got f of x divided by g of x. So when you see function operations, these are the same basic thing. And to solve or find or evaluate any of this, they got to give us some information. So if we just take this one in particular, I have f of x as x squared plus 2x plus 1, and I have g of x as x plus 1. And we can take this first one that is, that states f minus g of x. And so I would just take f of x here. Oops. So it's f of x minus g of x. So f of x is x squared plus 2x plus 1. I like to put mine in parentheses so I keep track of some things. And then, get the cap on there. Get my red pen. Subtract g of x. G of x is x plus 1. X plus 1. Don't forget that negative will mess some things up. So this becomes x, negative x minus 1. And then we have x squared plus 2x plus 1. Those are going to cancel. I'm going to get 2x minus x, which is x, so my answer is x squared minus x. So when you're dealing with these guys, these are just adding. It's pretty much straightforward. Multiplying, you use the area model if you need to. I'll show you. You can use synthetic division here. We'll do that with this one real quick. Other than that, it's pretty straightforward. Just keep track of your negative on this one. Remember, this is negative. This is addition, subtraction, addition, multiplication, and division as you kind of work through this. So let me show you the division one. So we're going to work with this one right here, and this is going to be f of g of x, of x. So if it's f of g of x, then we've got our purple one on top, x squared plus 2x plus 1. And we have our red one on the bottom, which is x plus 1. So you can factor this out if you'd like, using the area model or the box method or the big X method. This is going to be x plus 1 times x plus 1 all over x plus 1. I'll do that in red. I'm going to cancel that out, and my answer is going to be x plus 1. So, or you can do synthetic division and divide that if you want to when it comes to division. Remember, we don't care either way. All right, so that kind of gives us a quick idea of how to do all these different function operations. Just pay attention to which one they're giving you. All right, that brings us to this next part here, which is, I wanted that, f of x equals x squared plus 2x plus 1, and we wanted we're gonna use these for this. So let's look at this here. F of g of negative 2. So I'm gonna kind of change some colors on you. So we know that F right now is purple, so we're gonna put purple there. So, and we also know that red is G. So I'm gonna change some things here. So what I really want you to think about is this is two pieces of, these are two functions. This is a function inside a function, okay? This is G inside of F. So if you guys remember, off to the side here, if I had G of 1, that means right here that x equals 1. Because it would be like G of x. And I'm replacing x and 1. So x equals 1. So if we look at this, it really means that I need to find G of negative 2. So we're going to find G of negative 2 first. I'm going to work the inside. Inside first. So what's G of negative 2? Well, G of x is equal to x plus 1. So that means that G of negative 2 is equal to negative 2 plus 1. So G of negative 2 is equal to negative 1. Negative 2 plus 1. This is the piece of information I'm going to use. Because now I know that G of negative 2 equals negative 1. So now my new equation, I'm going to bring it down here, is f of negative 1. Where did I get the negative 1 from? Right here. Because G of negative 2 is equal to negative 1. So I found a G of negative 2. Once I found that answer, I'm going to take that answer and insert it into f, because that's what it's telling me to do. Now I take the f, and now f of negative 1, f of x is, well, I'll just leave that equal sign there. So we know that f of x is equal to x squared plus 2x plus 1. So that means f of, whoops, losing my pens, negative 1 is equal to negative 1 squared plus 2 times negative 1 plus 1. So if I clean all this up, this gives me 1, this gives me negative 2, and this gives me 1. 1 plus 1 is 2, negative 2 plus 2, so this is 0. Lucky that, I just figured that one out there. Didn't know it was going to be 0, but it is. So we know that this answer is 0. So find the inside of that one. Find the inside first. Use that answer to plug in to the next level. And my answer to this, or evaluating, this is evaluate. Evaluating functions looks like this. So first part of your assignment looks like that. All right. So let's tackle inverses. All right, so let me draw something up here for you guys real quick. So now we're down here, we're working on inverses. So we're working with inverses. So the simple theoretical idea is this, guys. If I take a graph and I take y equals x, which is the perfect linear line, 1 over 1 with this y-intercept of 0. And I say I have, let's just say, a point right here of 3 and 0. And that means that it's x and y, right? So if I just pick this point up and reflect it to the other side over here, so I'm just kind of picking it up and moving it over there, what happens to those? What happens to my x and y? My x and y switch, and I get 0 and -3. So the definition of an inverse is it reflects over y equals x. So in other words, when I go over to the other side of y equals x, my x becomes my y, and my y becomes my x. So when it reflects over y equals x, my x becomes my y, and my y becomes my x. So let's just take something like, let's go down 4 here, and over -2. So -4 and -2. Well, if I pick this up and move it, and it's going to be the same distance on both sides, well, I end up right here, which is going to be -2 and -4. So that's my inverse. That's my inverse point. Inverse means I go across. Now, if I drew this graph really good, which I didn't, you would notice that, let's just make it. You would notice that the distance would be the same from here to here. The distance on either side of y equals x would be the same. So that's the idea of inverses. So now we're going to take our knowledge of inverses, and we're going to say, okay, let's find an inverse. Well, we're going to find an inverse of y equals 4x minus 3. Oops. Okay, 4x minus 3. All right, guys? So, what do we know about inverses? We know that the x and the y switch. So, if I'm going to find an inverse, the x and the y switch. So, my y becomes x, and my x becomes y. Okay? So when we do the inverse, we just switch across the y equals x. So my x becomes y, and my y becomes x. So then what I do from there, I solve for y. So now we've got to solve for y. So if I solve for y, it's over here. I'm going to add -3 over there. And if you can't see it that way, go ahead and move these things. So I'm going to rearrange it for people that like to solve things this way, where the equation's on the left side. It's okay. You can do this. The whole thing has to move. So now I'm going to move the 3 over. So I'm going to add 3 to both sides, which is going to give me 4y equals x plus 3. Remember, I add 3 to both sides. And then I'm going to divide everything by 4. So that gives me y equals x plus 3 over 4. There we go. Y equals x plus 3 over 4 is the inverse to y equals 4x minus 3. Works for anything, guys. We can say like y equals x squared minus 3. And then we switch our x and our y, so we're going to get x equals y squared minus 3. We add 3 to both sides, so we get x plus 3 equals y squared. So if we have x plus 3 equals y squared, how do I get rid of the square? Take the square root of both sides, and I get the square root of x plus 3 equals y. There's my inverse of that one there. All right, guys, that's your intro to inverse of radicals, and operations of functions. So good luck, and we'll see you soon, guys.